Hi guys, for today's video we're going to be dealing with language and notation of angles. What I mean by language is pretty much just the words and the terms, etc., like what you see here, that have stuff to do with angles, and also some of the notations, some of the symbols, etc., like what you can see here, etc., that has to do with angles as well. Okay, so first up, adjacent angles. So they are two angles that share a line and vertex. So they have to share a line and a vertex, both things. And the vertex is another word for just like the point of an angle. So e.g. angle ACB and BCD are adjacent angles. If you can see here that the angle ACB, notice that our C has to be in the middle when we're saying this angle ACB because our point is at the C. So angle ACB is adjacent to BCD. So literally this angle here is adjacent to this angle here because they both share this line and they both share this vertex. They've both got their point at that same dot. Complementary angles, they're two adjacent angles that add up to 90. So two angles that are right next to each other and they have to add up to this 90-degree angle. So as you can see here, that X angle and that Y angle would have to add up to this total of 90 degrees. So that's why they're complementary. Supplementary angles, they are two adjacent angles that add up to 180 degrees. So angle ABC and angle CBD are supplementary. Notice that this angle and this angle, they both have their point at here at this B. So that's why you need to make sure your B is in the center for when you're naming these angles. Some of the notation sometimes is to put a little angle symbol on top of your middle letter. And these two angles here, so this angle here and this angle here, they add up to 180 degrees because they lie on a straight line. And a straight line makes a total of 180 degrees on top and on bottom. Angles in a revolution, they are two or more angles that share the same vertex, which adds to 360. So this angle here, and this angle here, X, Y, and Z, they add up to 360 because they share this vertex in the middle, this dot in the middle here. Another way to think about it is there's 360 degrees in like a full circle, and you can see here that we've got like a full circle going around with those three angles, so they must add up to 360 degrees. Vertically opposite angles, so they're two pairs of equal angles formed when two straight lines cross each other. So you can see here in this diagram, you've got two lines that cross each other, and they make two pairs. So a pair here, that's one pair. C and D, they're equal angles, and you've got another pair here with A and B. They're also equal angles. So we call these angles vertically opposite. So A and B are vertically opposite, as you can see here, and C and D are too, as you can see here. Okay, perpendicular lines. So they are two lines that cross at 90 degrees. Now the symbol for perpendicular lines is this. It's like an upside down T. And that means that two lines are going to hit each other at right angles, 90 degrees. So XY is perpendicular to AB because you can see that the line XY, so that line's called XY because the ends are X and Y, so that's our line right there. That's perpendicular to the line AB because where they cross at a right angle. If that's a right angle there, all these angles have to be right angles as well, because they're going to be vertically opposite as well. Like that and that should be the same because they're vertically opposite also. Okay, so some rules to remember. So when finding the value of unknown angles without a protractor, you need to show reasoning for your answer. So I'll just move that back over there. So the idea is we want to try and figure out this value of X in this example question. So there's our X angle there. We could just measure that angle with a protractor, this angle here, but we need to be able to do it without a protractor by having a look at the other stuff that we've got around here and giving reasoning for how we can figure out a value for this angle X. Okay, so what can we do to figure out that X? Well, first up, we can use these angles which I've given you. I've told you that's 90 degrees, and I've told you that's 140. And we can use some of these properties that we've gone through above here to help us out figure out what this x is. So first up, I've said that the angle DFE, so DFE, that's this angle in here that I'm shading. So this angle here, that is going to be equal to 180 take away this 140. And the reason is because this angle here and this angle here, they lie on a straight line and they are going to add up to 180. So we can do 180, take away what we've been given, and we'll be left over with this angle here that we don't want this angle, but if we figure this angle out, it'll help us figure out our value for x. So we can say that angle DFE is equal to 180 take away 140, that equals 40 degrees. So I could choose to put in my value of 40 degrees in there to kind of complete my diagram a little bit more. And it's really important to put your reasoning. So here I put in the reasoning next to that these two angles here and here are supplementary. They add up to 180 degrees. So it's important to show your reasoning to see, because we as markers want to see how you're getting these answers. Okay, next up, angle AFB. So angle AFB, so AFB, so it's going to be this angle right here. That is going to be equal to 40 degrees, and the reasoning is because they're vertically opposite angles. So I can put in there a 40 degree to keep going with my to kind of complete my diagram as best as possible. And you can see here the reason that I had was because these two lines are vertically opposite. They make a cross shape, and these two angles are equal because they're making an equal pair with each other. They're kind of like straight across from each other with that cross. Okay, and so now that we've got that, I can pretty much look at all these angles going around the circle and think that they all add up to 360 because they're all lying at this middle point. They're all around this point. It makes like a full circle here. So they all add up to 360. So I can do 360, take away all these values that I have, and I'll be left over with what I want, this x. Okay, so let's do that. So 360, take away 140, take away two lots of 40, take away the 90 degree angles, and I'm left over with 50 when I put that into a calculator. And notice the reason is because all these angles form a revolution around that point. So I've shown my reasoning and I've figured out that my x value is 50 degrees. So, and that's exactly what I was trying to figure out, what that angle is. It's a 50 degree angle. Okay, I hope this helps with some of the questions. Good luck.